Okay, so hello everyone, I'm Dinesh. I unfortunately wasn't able to come to the last class as I had something come up, but I did hear Stephen did a great job teaching everyone, so I'm gonna be taking on teaching from now on. So now we're gonna go on to chapter 11, which is special factorizations. So what these are an extension of what Stephen taught last class. Last class we talked about basic factorizations with just quadratics and general factorization. Today, we're only going to be focusing on special cases with unique identities. So what I want you guys to do is first try to do this problem. I'm going to give you three to 4 minutes, and then after that, we'll review it. So what this question is asking you to do is take those and then square them out and expand them completely. So I'm going to give you a few minutes to do that. Also, when you guys are done, just use one of your reactions so I can tell when you're done so I can help explain this question. Okay, I'm starting to see a lot of answers come in, so we're gonna go review this problem. So these are the two solutions. The first one is y squared plus 10y plus 25. So the second one is y 9z squared plus 48z plus 64. So if you got those right, great job. If you didn't, essentially all we've done here is we've used the FOIL method to expand them out. I believe we talked about that in the last class. So you multiply the y's, then the 5 times the y twice, and then the 5's at the end, and you do the same thing for the second question. So what the importance of this is that you start to see a pattern here where it becomes a squared, which is y, which becomes y squared, and then you get 2ab, which is where you multiply the 5 by the y, and then you multiply that by 2 again, because you have to do that twice. And then at the end, you do the 5's and you square them, and then you get that answer right there. So that's essentially all this is, but this is very basic to what we're going to learn later in the class. So this is just something you should keep in mind, that when it's the same thing squared, you always end up with this pattern. Okay, so there's a lot of parts to this one. So what we're doing here is that we're essentially doing the reverse of the last problem. So these are all solutions, and then you have to figure out if there's a square of a binomial, and if there is, you have to be able to determine what it is. And if it's not, just mention that it's not. When you guys are done, either just put your answer in the chat or put a reaction up so I know when we're ready to go on. Okay, I did receive a few answers on this one, so I'm going to start explaining it. But if at any time you guys feel that I'm going too fast, just send it in the chat or to either Stephen and I, and then we'll slow down to make sure you have enough time to do them. So for this one, the answer to A was x squared minus 6x plus 9. So what you see here is that A would be x and B would be 3. And when you square this out, you realize that you get the x squared, you get the 3, and then you get 2 times A times B, which would be 6x, negative 6x, which is how you get this. With B, what occurred is that here these two terms again get squared, so it would be y plus 5. However, there's no way you can get this middle term with 2ab, which is why this one isn't a square. The reason why C isn't a square is that the middle term is negative, which is something we're going to get to later. I'm going to explain that, and the same with E as well. So then so what happens is these two, this one is a square because what happened is when you square the fraction, you get 1/4, which is why that's possible. And then for letter E, also the constant is negative, which means it's not possible to be a square. With F, the case is that it follows the whole a squared plus 2ab plus b squared. So the main pattern I wanted for you guys to take from this is that this term and the first and the last term always have to be positive, because what's going to happen is you're going to take the same term and you're going to square it. So whenever you square two positives or two negatives, you'll always get a positive. So if the first term or the last term is negative, then there's no way it can be a square. And then this is a concept I wanted to explain really quickly. It's called Pascal's triangle. So essentially what it is you take a triangle with 3 ones, and then you add these two numbers together to get this number, and you keep adding numbers to keep getting numbers further down this triangle. So what's special about this is that it works with our squares. So when it's x plus y to 0, the coefficient is 1. Well, it's 0, which turns into 1, and then you have x plus y to the first, where you get 1 and 1, and then this pattern of 1 2 1 follows down all the way through the triangle. So that's how these squares work. It follows this pattern called Pascal's triangle. So now we're going to talk about something different. Before we talked about squaring we talk about squaring the same thing. So here we're going to talk about a concept called the difference of squares. So I want you guys to try to do all 4 of these problems, and then either send your answers in the chat or just give me a reaction when you're done, and then we're going to go over this. Okay, I've started to see that there's a few answers coming in, so I think we're gonna call this one and then we're gonna go to the explanation. So these are the answers to those questions, and the first thing I want you to realize here is that all these are very similar to the ones we did before where we just square the same term. However, what you'll realize is that they're the same except for the fact that one has a negative and the other has a positive in them. So what this actually does is when you multiply this out with FOIL, you get your x squared and then you get your -1. However, when you multiply the inside and the outside, you get exact opposites that cancel each other out, which means that you'll never have a b term because in this one you get -1x and positive x, which cancel. Here it's -2x and positive 2x, which cancel out. So you'll never have a linear term. You'll always have your quadratic term and you'll have your constant term. So that's what's unique about these cases. So that's what I was just explaining. This is, if you're looking for a formula, this is a very concise way of explaining it. And the way you can always tell is that difference of squares for quadratics will never have a linear term at all. So here's a challenge problem for you to do. I think this one's going to take you a while, so I'll give you 6 or 7 minutes to try. It is a very difficult problem, so if you don't get it, don't worry about it. I'll explain it later, but give it your best shot. Also, type your answers in the chat once you have them, and then I'll know when to move on. I'm going to give you guys 2 or 3 more minutes on this problem. All right. I think that's been about 7 minutes, so we're gonna call this one. Does anyone think they have a possible answer that they might know for this one? Even if you've just got one part, does anyone have anything? Even part A or part B? What about, let's see.
Kristen Huang is raising, I think, his or her hand.
Oh, yeah, Kristen, go ahead.
I think one of the solutions is m equals 13 and n equals 8.
Okay, let's take a look. Yes, that is correct. That is one of the answers. Does anyone else want to try for any of the others?
There's one that's 53 and another that's 52. 19 and 16 and 11 and 4.
Yep, I believe that's all of them. I think I accidentally hit this slide a few times while you were working on it. But for the others who might have not understood it, I'm going to explain it a little bit. So essentially, this is the equation we started off with. And what we decided to do is we subtracted the n squared onto the other side, like m squared minus n squared equals 105. And what we learned from the last one is that when we have this is a difference of squares where you'll end up with this. So all we've done is we've deconstructed that quadratic to make it something easier to work with. So we have m minus 1 quantity times m plus 1 quantity equals 105. And so we also know that m and n are integers. So that's also something we want to be aware of so we don't get any decimal answers. And also what we now know is that m and n also have to be factors of 105 because when you multiply one by the other, you have to get 105. So we know that they have to be different factors of that. So the four possible factors were 1 times 105, 3 times 35, 5 times 21, 7 times 15. Now, some of you might be asking why we didn't use negatives, like -1 times -105. And the reason for that is because in the question, it says find only positive integers. So we can only use positive ones. So what we do is we actually set up all of these equations like this, and then we set them equal to a different factor every time because this is essentially a systems of equations. So when we do this, what we do is we can add these together, we can manipulate them, and then we'll eventually get all of these four solutions right here. 53, 52, 19, 16, 13, 8, 11, 4. So nice job to Kristen and Jeffrey, I believe, for getting that challenge problem. So now we're going to move on to another type of special factorization. This is the sum and difference of cubes. So before I start explaining it, I want you guys to try to do all four parts of these. So this might take you a little while, so I'll give you, again, 6 or 7 minutes before I start calling on anyone.
Also, type in chat if you're done. Don't do reactions.
So far, I've just had one person tell me that they've got the answer. So if anyone else has the answers, just type in the chat that you're done, so I'll know how many of you are ready to go. Okay, so I've had a few more answers come in, so we're gonna go on to the explanation for this problem. So when you expand out all the answers, these should be the answers you get right here. So essentially they simplify down a lot is essentially what we're getting at here. And then when we follow this pattern, what we should expect is that we get this answer right here. If you realize these are just a pattern where it's just the cube root, if you cube root each term, you'll get the first term, and then you just take the remainder and you make that the second term. So this is just expanding on the difference of squares kind of onto another dimension. And then what we end up with is we end up with this extra term here and then this normal term here. So what we get is we essentially get the cube root, which is a third square root essentially of both of these terms in this part. And then we get what looks like essentially the square of a binomial in the second part. So that's essentially all we've done in this case. So again, we're going to go on to another challenge problem here. This is very similar to this last problem here with these cubes. So one hint I'll give you before I set you off is try cross multiplying these proportions out and see if that helps you. This is a really challenging problem, so I'm going to give you guys like 8 or 9 minutes. And then since this is a challenge problem, I'm going to call on someone or ask someone to volunteer their answers. So far, I've gotten one answer in. So if any of you guys have any answers, type them in the chat. I'm gonna review how to do this problem in 1 or 2 minutes. Okay, so I did have one student uh, send me in the right answer. So the correct answer for this was the cube root of 14. So I'm gonna quickly go over how to do this problem. So the first thing we did is we actually cross multiplied the first one out, and then when you do this, you start to realize that these are just factorizations of cubes that we learned about a few slides ago. So if you actually simplify these, you'll get x cubed plus y cubed equals 1 cubed plus z cubed. And then that's the same thing you have to do with the second equation as well. And then when you do that, you get x cubed minus y cubed equals 27 minus z cubed. So now you have these two equations, you put them next to each other, and essentially all you do is a system of equations. Since if you add these two equations together, these two cancel out and these two cancel out. So you get 2x cubed equals 28. And if you divide that by 2, you get x cubed equals 14. And then if you take the cube root, you'll get x equals the cube root of 14. So I think that problem, if you were able to identify these, it should have been pretty easy for you guys to do. So if that's where you were stuck, then I highly recommend you go back to this slide here and try to be able to recognize these patterns, because these are the patterns that were used in that problem. Here's the next problem. So rationalizing denominators. So essentially what we mean by rationalizing a denominator is taking the square root or the cube root or whatever root out of the denominator. So I'm going to give you guys maybe somewhere between 5 and 10 minutes for you guys to do these, and then send them in the chat, either in the chat, say you're done, or send in the answers so I'll know when you guys are ready. So has anyone gotten an answer for part A? Just unmute yourself and just shout out an answer if you think you have one. Jeffrey or Kristen, do you have any idea what the answer to part A might be, or Hugo or anyone? Anyone want to try to give it a shot?
Wait, so for part A, is it 1 or 2?
Could you say that again?
Part A, is it 1 or 2? Like, do I have to do 1 or do I have to do 2?
So essentially you have to do 2.
Oh, okay. So I got square root of 2 divided by 2.
Square root of 2 divided by 2. Okay, so that is a great answer, except there is one thing, well, actually that will work. Do you actually have an answer for part B as well?
Part B? No, I don't have
I'm-
the answer for part B yet.
Okay, so yeah, what you did, I believe, should be a right answer. However, there is a easier way to do it. Essentially, what we do is we take the denominator and then we put that in the numerator and the denominator. So what we do is if we have 1 over root 2, we multiply that by root 2 over root 2.
Oh,
So
that's
your
right,
way, could you say that again?
but that's what I did.
Oh, okay. I thought you didn't say root 2 on the bottom. So, okay, yeah. And then you did it the correct way. So essentially what this does is then it takes out our square roots and then it just leaves a square root on the top. So this way it's square root of 2 over 2, which is what we want. And part B is a little more complicated. So what we actually need to do is we need to take the cube root of 3. That part's correct. However, we also need to put a square on the inside. The reason for that is we want the exponent here and the root to cancel out. So if we just multiply by cube root of 3 over cube root of 3, we would end up with the cube root of 3 squared, which wouldn't actually get us an integer because we need the cube number to match and the exponent number to match. Since here these are both this is essentially just 2. If we multiply these two together, it would be 2 squared, square root of 2 squared, so those will cancel out. So then here is another one. So I'm going to give you guys, again, 5 to 10 minutes to try this one out. My hint with this one is try to use the difference, I believe it was the difference of squares that we talked about earlier. That's your hint on how to do this one.
So for A, I got square root of 7 plus square root of 6. And then
Yeah, that's the answer for part B as well. So since Jeffrey solved this one, we're going to move on and then I'm going to help explain it. So essentially, this is the difference of squares factorization. Oops, this is the difference of squares factorization we talked about earlier. So essentially all we've done is, since we have a negative here, if we make that a positive, what happens is that the square root of 7 and the square root of 7 will just equal 7. These two will just equal square root of 6 squared, and then you put a negative in front. And then when you multiply these two together, they cancel cancel out these two. So you all will always end up with an integer in this case. So that's the trick. We have to use that concept of difference of squares we learned about earlier and then put that into this example right here. And here's the exact work for it as well. And then this is how we end up with that.
I'm pretty
So
sure we learned this. Like,
last session?
I think we learned this in like a previous slide.
Yeah, we did. So the idea with this though is that we wanted the idea of this problem is that in the previous problem, we just had one thing in the denominator. So what I was trying to get at here is that when you have multiple things, you have to use that difference of squares we talked about earlier. So this is combining the concept of rationalizing denominators and the difference of squares. So here's another challenge problem for this one. So for this one, I'll also give you another 10 minutes to do it since this one might be a little more difficult. And what I want you guys to do for this one is type the answers in the chat, and then I'm going to respond to you if they were right or wrong.
Like, is the answer is the answer square root of 12 plus square root of 18 minus square root of 30 all divided by 12?
Yeah, that's correct, but try to simplify those square roots by taking out any common factors, and then
So
and then
it's
type your
2.
answer. And I'm gonna give, yeah, go ahead.
I don't know how to type the square root sign.
Okay, just type in SQRT, and then I'll know.
Oh,
Okay, so I did have two people. They were Sharon and Jeffrey, who both did end up getting the right answer. So now what we're going to do is I'm going to explain this one to you. So this, again, like the last problem, we have to use the difference of squares. However, the way we do this problem is a little unique. So what we do is there's no definite way to take out all three of these. So what we do is we actually put parentheses around two of them and make them their own term. So in this case, we just went around the first two. And then what we can do here is, since we're multiplying by the same thing in the numerator and the denominator, that means this whole thing is only equal to 1, which makes it legal to do this. And so what we've done is we've done the square root of 2 plus 3 minus the square root of 5. So this is very similar to the difference of squares thing we did earlier. So when we do this, the numeric goes over, the denominator gets this term, and then the inside and the outside cancel each other out. So then after that, what we do is we expand this out. So we get 2 from 2 squared, 3 from 3 squared, and then the -5 from this term, and then we get this middle term here. That's kind of in our way. So now what we do is we simplify this even further, because this 2, this 3, and this 5 actually all cancel out. So we just end up with this here. After that, what we do is we multiply by the square root of 6 in the numerator and denominator, and then this actually will come into here and it'll become the square root of 36, and this will just multiply through all of these terms again, and then we get 2 root 36, and then the square root of 36 is 6. If we multiply that by 2, we get 12, and so that's how we get to our final answer. So essentially this one just requires some more creativity, so that's essentially what it is. And then here we have another challenge problem that I'm going to give you. So this one is where we have this equation here, mn plus m plus n equals 76. And what we need to do is we need to figure out all the possible solutions where m and n are integers and they will satisfy this equation. So the hints for this problem are they give you a few steps for you to go through. So if you follow these steps, it should make the problem much easier for you to do. So I'll give you again somewhere between 5 and 10 minutes to do this problem as well. Okay, so I think we're gonna call this one. So we're gonna get through this one quickly because Steven actually made a Kahoot for us to do as well. So essentially all we've done here is that we factored out the m out of this. We get m times n plus 1 plus n equals 76. And then we added 1 to both sides of the equation here. And then since we have these identical terms, what we can do is we can add a 1 in front And we can actually make it into a quadrat. We can make it into not a quadrat, but two binomials. So then we end up with m plus 1 times n plus 1 equals 77. And we realize that the only way to factor this is 11 times 7. So one of these has to equal 11, the other has to equal 7. And when we know that, that must mean m is 10 and n is 6, or m is 6 and n is 10. That's how we can do that. And then there's one last challenge problem that I'm going to have you guys try to do. I'll give you 5 minutes for this one. And then again, just type your answers in the chat if you know it. Okay, so I do have some answers coming in. So I think I'm going to start off by explaining this one. So the question only asked for how many ordered pairs there were, which is the answer is 4. So how we ended up getting to that conclusion is we did the same thing as before, where we subtracted these two over, and we made it into two binomials that we can multiply again. So when we have this, what we can do is, since we need we need a negative 4n and a negative 2m term. So when we factor this out, we can get m minus 4, n minus 2, and this will equal all of this. However, what we didn't account for is that we need an 8. So on the other side, so we add that 8 in, and then we realize that it's m minus 4 times n minus 2 equals 8, because in this original equation here, it equaled 0, but that's not what it equals. So we account for that, we make it equal to 8. And then we do the same thing as before, where we factor this side. So we get 8, 1, 4, and 2. And then what we do here is we essentially just set up another systems of equations like in that previous problem. And then when we do this, we can figure out what all of our answers are. So that's all I have for this this class. I just wanted to remind everyone that on Sunday, Stephen and I will be having a Zoom from 7 to 8 p.m. Central Daylight Time on Zoom. You should have already gotten a link from Cloud Classroom. So essentially what office hours are is, if you had any questions about this lecture or last week's lecture, or any of the homework, if you come to that session, you can ask us your questions, and then Stephen and I will try to explain those to you, and any other doubts in any different ways or other ways if you didn't understand the way we did it. And the same goes for homework. You can ask about homework questions. And then as for the homework, it's optional, but I recommend you do it as it's beneficial for you. And I'll be sending that out in an email within the next 24 hours. And then that's it for this session. However, Stephen will be playing a Kahoot with you guys that he made for this session. So yeah.
Yeah. I'm just start it right now, and just a second. I'm trying to find the link. Is this the one? Are you guys seeing Kahoot?
Yeah, we see it.
Okay, so just join the pen and stuff.
How in the world do people join so fast?
We have quick fingers.
Or your Wi-Fi is just too good.
Maybe I have Kahoot on
My Wi-Fi should have been thrown in the trash.
Who is period? Because okay. I'm gonna change my nickname.
Okay, guys, let's go quick. I'll start it in like 1 more minute. Okay.
Alvin, what's your username?
Not telling ya.
I think you might be the code.
Maybe.
The 331342.
Maybe.
Everything's maybe.
I'm 331342, the game pin.
Oh,
Maybe I'm the game pin. Maybe I'm not.
maybe you're WW.
Or maybe I'm not, or maybe I am.
Well, I want to start the Kahoot now. If you guys want to join later, there's a
I think they're
code.
fine.
While we're there's still the code is still gonna be on the presentation like when we start it. So
Someone named F just joined on the last second.
nice.
Bruh.
My brain goes burr.
Bruh. I literally can't click. Six answers? Let's go. I really think Alvin is CCCC. I'm GXCS. Oh, well. I guess. Oh, Chris is CCCCC. Wait, Lila, you can still join, you know.
For those of you who like pick the green one, remember you have to like there's x plus y and x plus y and FOIL them out. You can't just square in the insides. Okay.
Oh, I'm so tired. Why are you dumping your Wi-Fi in my garbage, Alvin? Yo, I'm in first place.
Nice, Jeffrey.
Where does CCCC go?
The equation is small, but it's ax squared plus bx plus c equals 0 if you have trouble seeing it.
Screw it. No, nickname Go Burr. You have defeated me.
What the?
Oh, didn't we do this question? Why is there so much time on this? Now we just have to wait like 70 seconds.
I can skip it. Once basically everybody has answered.
I think there's one alt account, so like that doesn't answer. So
Okay. Sure. Okay. Yeah. Okay.
how? Nickname. I hate nickname. Wait a minute. Yeah, I got that wrong. Oh wait, am I the only person who got it right?
Yeah, so guys, remember the zero product property, you have to set x plus 4 equal to 0, and you subtract 4 to get x equals negative 4. And okay, wait, my bad, I did this problem wrong. It's supposed to be negative 4, 0, not 0, negative 4.
Oh my
So-
god.
That's
I
quite
guessed
unlucky.
it.
Go again.
You have to refund my points.
That was funny.
Yeah, so this equation, x minus 3 squared, remember, just since they have two x minus 3s, you just use one of them. So x minus 3 equals 0, you add 3, and you get 1 root. And that's the only root you have for this equation.
Oh, period has two alts. So.
Thank goodness nickname Gilbert is first again.
Why do you not want me to be in first?
Because I'm nicknamed Gilbert.
Oh, okay. Ha, now I know your identity.
So what?
Your secret identity.
How is that secret?
Now it's not a secret.
Yeah, I never intended it to be a secret either.
You didn't even tell me your username, so how would I was supposed to know?
Wait,
What the?
okay, this is also wrong. Okay, my bad, guys. It's supposed to be
What is
blue.
this?
Can I?
Refund the points. You have to refund.
Is there a way to see who got the answers? Okay, there isn't.
I
Okay,
want to see
my
your
bad, guys. I'm sorry. But
I
this is
need
good
the-
practice.
What was that? I am 39 points behind.
How in the world?
Refund one of my alts correct.
Okay.
Bum, bum, bum.
Yeah. The last one.
Wow.
Okay, good job.
Second place. Not bad. Okay. Hug. Making him go bird.
Okay, good job, everybody. Sorry if some of the questions were wrong.
Well, thank goodness
Yeah.
I still was first place, even though, well, I should have gotten two extra questions correct.
Okay, nice.
Hey. Bum, 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 bum. Oh yeah, ASDF movie 14's out.
So Dinesh, do you want to end the class or?
Yep, we're done, everyone. So I'll send an email out later tonight with the office hours, timings, and the homework as well. So thanks for everyone that came to class today, and goodbye.
Bye.